everybody. Thank you for joining us. We're here to talk about communications convergence. And first, let me have a moment to tell you about the IoT M&M Council, who's sponsoring this session. It is the world's largest trade organization focused entirely on the Internet of Things. So if you want to learn more about that, please come and see us downstairs in the IoT Infrastructure Pavilion. With that, I will introduce myself. I'm Sarah Brown. I'll be your moderator. And I will pass the baton over to Alistair to tell us a little bit about himself.
I'm Alistair Fulton. I'm COO of a company called Blues. We have a little stand downstairs. You can come and see us. And we're focused on really making it simple to connect any machine to the cloud to make it intelligent. My background is in and around this space. I used to run Semtech's IoT division, so LoRaWAN, and before that I've spent some time building IoT platforms.
Hello, everyone. Good morning. My name is Carmen Redondo. I work at Kyocera IBX. We are the division from Kyocera Corporation in charge of advanced electronic components. We cover everything from connectors, sensors, capacitors, and antennas, which is what I'm in charge of. My background, I'm an antenna engineer, and right now I'm the director of global marketing at Kyocera IBX.
Hi, everyone. Welcome. My name's Rick Summerton. I'm the CEO of ESAC Global. We're building a low-power proprietary IoT system to deliver low-cost connectivity globally.
Good morning, everyone. I'm Dwayne Wald. I'm with Multitech Systems as the Chief Product Officer. Multitech is a technology company with a focus on bringing gateways, routers, modems, and connected sensors to the industrial IoT market. We're headquartered in Minneapolis, in Minnesota. We have a global presence. So it's good to be here today. Thanks, Sarah.
Yeah, thank you all for joining. Before we dive in, I want to encourage everyone. We really want this to be a two-way conversation. So please don't hesitate to raise your hand if you have a question. We're very happy to talk with you about it. But to start, when we did our prep call for this session, we had quite a few different opinions about what exactly do we mean by convergence. And so I just want to start, and we'll go the opposite direction and start with Dwayne, and just have each of you tell me, what do you mean when you think of the word convergence when it comes to connectivity for IoT?
Every generation, there's new tech being invented, developed. This is a group of engineers that love to design things and figure out and solve problems. So every generation, every new technology needs to figure out how it's going to work with the past and also with the future. I think convergence in our world is about how do we kind of blend those two together? How do we make it seamless to kind of keep the investments of the past, but yet bring them into the future, and then going forward, how do you kind of adopt the new technology? So our path is we kind of play in the IoT stack from the edge to the cloud, kind of in this middle piece. So we're trying to bridge and be a conduit for connecting from the edge to the cloud.
What about you, Rick?
Well, for me, it's an interesting story because we've got a proprietary system, and we're talking about 5G across satellite. What we see in 5G is a system that's being tried to be crammed into a satellite environment, and so far it's not. We can see that it's not going to deliver for the IoT space. It's going to take some time, and there's a lot of interest about this. But when we speak to satellite operators, when we hear telcos talking about this, and then we hear users, they all talk about it, but today we don't see the uptake happening because of various issues. I mean, if you look at satellites, just aren't there yet in the low Earth orbit, in the geo orbit where we look at. They're still trying to implement and work it out, and still work out if the business model works. But for us, the benefit is now that we have a whole bunch of chip manufacturers building chips that work on satellites, specifically in L-band for us. And it means with satellite-defined, software-defined radio, that we can actually slide in behind them, and that gives us an opportunity to really reduce our hardware costs.
Cool.
So for Kyocera IBX, talking front antenna, which is always the forgotten component, I will say, everybody talks about the modules, what technology to use, but of course for wireless devices, you need an antenna, on several antennas in this case. So for us, convergence is how to make the coexistence of all these technologies in a device, especially in IoT. Every time there are more and more technologies. You have the cellular ones, but now the satellite IoT. You have Bluetooth, ultra-wideband as well for indoor location. So there are some considerations depending on the technology you have that you need to have into account. You need to make sure the isolation between them, and there's a lot of factors to take into account. It's not about just covering the frequency. So for us, the goal is to have devices that will connect anywhere. We choose the best technology, and I think for us, what means convergence and what we are towards with our partners.
Okay.
I think convergence is another one of the buzzwords that we've come up in this industry. That I think when you talk to engineers about what they want, they don't care about convergence. What they want is simple, and what they want is easy. And that means in the context of connected hardware, it means that the software layer is as similar as it can be across different radios, and the back end, where the data goes and the format that that data travels in, is as similar as possible. But when you're talking about embedded devices specifically, the notion of converging multiple radios on a single device, whilst it's physically possible, and with clever antenna technology, you can accommodate 5G and satellite, et cetera, very often for connected devices, that makes the cost equation unworkable. And the cost, both in terms of the actual physical hardware cost of the device, but also the cost of powering that device. So the battery that you have to have on board to support multiple radios is substantially bigger and therefore more expensive, both in physical cost and in servicing cost when it runs out, than a battery that's required to support a single technology. So Blue's approach to this problem is really actually to focus on those two layers, to focus on the software layer and make the code base the same, regardless of which radio technology you're using, building a plug-and-play solution for multiple radio types, so you can go from a Wi-Fi-based product to a satellite-based product simply by pulling a card out and putting another one in, and making sure that the data that flows off the back of these devices is compatible and usable. I think what's happened over the years of IoT is that for varying reasons, technology providers have built incompatibility into their product by design. Sometimes it's because it's easier to actually build a solution if you're just focusing on your particular technology. Sometimes it's for competitive reasons. Sometimes it's because VCs wanted to see a nice big return. Sometimes it's market capture. But there are various reasons why we've ended up in this place where none of these technologies really work with each other that well. And I'd argue that talking about convergence is kind of the wrong focus. We should talk about simple and actually look at how we make the development process, the deployment process, and the management process super simple, regardless of which technology you choose.
Okay.
That's interesting because when I go to MWC every year, it's all about 5G, and there is this. What I see there is this huge machine that just needs to expand and expand and expand to grab as much of the market as it can, and so they only have one focus. And convergence is something that's really important to the 5G guys, but what I'm hearing from you is it's less important from a user perspective.
Yeah, I mean, I think the cellular providers, and I, like many of us, spent a number of years in the cellular market before moving into this space like 20 years ago. It's like the Intel model. Intel sold an awful lot of microprocessors because the workload that was imposed on those microprocessors increased exponentially year by year by year. Now, you could argue whether the functionality that was delivered to the user got that much better as you went from Windows version to Windows version, but it meant every 3 years you had to buy a new PC. And the phone market is exactly the same. I don't know that for a lot of applications in the IoT space, there are not many applications where high bandwidth 5G, and now it's 6G. When I was at MWC, I was like, please, someone shoot me. We haven't even finished deploying 5G. It's that constant cycle that's driven by technology vendors.
Yes.
Very often in absence of any input or understanding of what the customer's actually trying to do. And what they're trying to do is they're trying to connect an ear tag on a cow, and they're trying to make it last for 10 years. And they want it to be cheap, and they want it to be simple, and they want it to be... And we're constantly, as an industry, bombarding these customers with the next thing, the next thing, the next thing. Now it's AI. The bewilderment amongst most customers is extreme, and most give up. Or they get stuck in pilot stage, and then the new thing comes along, and they have to pivot to that. And so I think we've done as an industry and I count myself in this as well, a fairly terrible job in delivering what customers need in the form of simple ways to connect.
We need to talk after this. This is a cow tag, by the way.
Oh, there you go.
I just brought along. You won't like to see that, though.
Nope.
That's a printed antenna, so it's when we make the PC board, the antenna comes on it, and that'll, believe it or not, we get fantastic link margins communicating with the satellite from a cow's ear.
Yeah, but that's a simple application that requires a relatively simple solution, right? I worked once years ago on a tracker that we built it. It did everything that you could ever possibly imagine you wanted a tracker to do. It had 10 radios on it. I mean, it was ridiculous. It was so over-engineered, we couldn't move them at all. I mean, they were sitting on a shelf. Nobody could afford them. Nobody could figure out how to use them. It had a lot of added technology that just wasn't necessary to the application. Now, Dwayne, you guys are building devices that combine multiple radio protocols. Tell me, what are the use cases where you see those being deployed, and to what degree are they really using all of the radios that you've built into those things?
Yeah, I think to Alistair's point, it is complex. I think the technology or ecosystem's fragmented. We build spot devices, and then no one ever takes the time to actually integrate them and create a nice, seamless end-to-end offering, and with few exceptions. And I think the use cases are very diverse. So it's very difficult to do them all from one vendor. So you have to build interoperability. You've got to have a strategy around working with companies that actually have the same view as you, and how do we create simplicity for the customer? How do we kind of create software stacks? How do we create interfaces that are common that can be seamlessly integrated all the way through to from edge to cloud? So we've kind of put in a strategy around, we talk about compute at the edge, we talk about intelligent devices. What we use that intelligence for, what we use our compute power for, is actually trying to harmonize and normalize protocols, et cetera. And then from a standpoint of some of the wireless technologies, whether it's 4G, 5G, LoRaWAN technology, BLE, Bluetooth, or even Wi-Fi, it's really about leveraging that to kind of create that seamless experience. But we need to kind of harmonize all these different elements to create simplicity for the customer.
What have been the drawbacks or setbacks that you've encountered in developing and deploying those types of devices?
Well, from a standpoint of the multiple wireless approach, it's really about how do you leverage networks, and not about trying to create a one-size-fits-all, because I think that's the challenge with the price performance. It's really about how do you leverage wireless technologies in unison? How do you kind of extend your networks? And so, as an example, all of our gateways are backhauled over 4G or 5G technologies. But LoRaWAN is also a key component of it. We extend miles with LoRaWAN to backhaul over public or private cellular networks. The same thing we can do, we're actually doing this with also BLE. BLE to LoRaWAN also is another extension of a wireless technology. So you have to look at technology in context of value, and also the use cases and how you can stitch it all together seamlessly. And not just so it works, but the user experience has to be something that can be scalable, how to be managed, and how is it economically viable to actually deploy such a solution. So that's where we focus on that area of the technology stack around how do we bring all the pieces on the southbound, northbound pieces together to make it seamless for the customer.
And I do think the infrastructure, kind of combined radio infrastructure play that Multitech has kind of pioneered, and the exceptional gateway products that you produced in LoRaWAN in the early days were extremely helpful to the propagation of that technology. But if you're putting a box in situ with a power line to it, why not put more than one radio into that box? If you can service Wi-Fi in the local area, LoRaWAN, as you use cellular as a backhaul, that makes a lot of sense. I think the stray of that convergence model into the endpoint makes far less sense. But at the network infrastructure level, if you're pulling a cable and providing power, PoE to a box somewhere, help make that box as many radios as possible if you've got the need in the environment that you're in.
Yeah, it comes down to the business model and who's going to actually own that piece of it, and who's going to take advantage of the services that it can offer to the market and around you. Is it a customer is it a building owner? Is it part of public infrastructure? And each of the technologies has different characteristics, so its performance is going to be different. And so you have to understand like what use cases you can support on it. I mean, the idea of that in a lot of LoRaWAN cases, we have multiple gateways in the same building servicing different use cases. Yes, but to bring that together and harmonize that to a service provider that can offer that as a service out, it's not mature enough yet. I think it's going to come. Just like you have Wi-Fi service in a building, I have a guest network, I've got a private network. I think some of these technologies will, especially in the LoRaWAN space, where I see it, is going to eventually kind of converge into that sort of model. I think that's one of the biggest use cases we have is in that smart building or building automation space. I mean, this is not new. This is not a new use case. I mean, it's HVAC, it's heating, ventilation, air conditioning. Makes us all comfortable in this room here. Air quality. To do that with technology of the past is very expensive to install, to maintain. Wireless technologies, it makes it much simpler. But yet you've got the incumbent protocols of the past merging with the new protocols of today. That's where we need to kind of bring and harmonize these protocols, both on a wireless side as well as software side, to make these things seamlessly to integrate and use.
If we put on our consumer hats and think about, I like to kind of think about convergence backwards, not just about how we build it all into one box, but how we engage with different communications in our environment, right? So we're in this room. There's Wi-Fi. We've all got cell phones. There's LoRaWAN operating the HVAC. All kinds of, we've got BLE headsets on. There's all kinds of different communications that we're all engaging with in every moment. It's true also in our homes and in our cars. So when you look at it that way, how do we, I should say, create a harmonic situation between all the different applications of our daily life?
I think it's incredibly hard. I think part of it, the reason it's hard is that you have very large vendors who are trying to build walled gardens, and I've worked with a couple of them, and one of them, who I shall not name, said, I want the incremental cost of connecting everything to be zero, which as a hardware vendor was quite an interesting conversation to have, as you can imagine, but I want it not to work with anything else. And when you have, in my home, I have 5 or 6 different solutions. I've got Ring, I've got Nest, I've got the Lexus in the Ring, I've a whole bunch of different things. I've literally no idea how to make them work together. So they each require a different level of understanding. Periodically the light bulbs will stop working. Honestly, I just buy more light bulbs because it's too hard to figure out how to update the firmware. And if I think that's representative of a lot of consumers' experiences. They want to know when someone's at the front door. They want to be able to relate that to switching the lights on. They want to relate that to being able to turn the temperature up in the house. And at the moment, that's impossible, because none of those systems are deliberately designed, I would argue, not to work with one another for largely competitive reasons.
Interesting.
What a great analogy. I love that because I'm a tech guy. I've got hardly anything smart at home because I can't be bothered. It's too hard.
But Sarah, I think we are also missing a lot of new applications that we are bringing now in the topic, like satellite IoT. Mm-hmm. I mean, 71% of the world is not covered by terrestrial coverage. And it brings a lot of new use cases, like in oil and gas, tracking, you want to have from one continent to another. And I think this is when the real convergence is going to happen. Yeah. And this year, I'm aware, is going to be the first hybrid devices will come into market. This is what we are working on. I think it's very important to have this into mind, because I really agree we need to make it simpler. That's why it's very important, the ecosystems to partners, I think is, not only thinking of the connectivity or in the module or the antenna. I think it's very important to, from the very, very beginning, to put all the pieces, to make your puzzle and to make sure it works. And that's why I think is, compared to many years ago when IoT started, I see that there is a lot of cooperation between companies, and trying to make things easier. We have in our booth reference designs, either, with Skylo, with for EcoStar, with LoRaWAN, and I think this is very important to also have this into mind.
Yeah. As a marketer, I also think we have to be careful how we talk about where we are in time and space, right? Because we talk about 5G with satellite, and we're just at the very beginning of that. I mean, we have customers testing it now, but they won't be deployed with a real world solution for quite some time. And so I think, to your point, I think it was Rick or Alistair about Mobile World Congress, where they've gone on, and now they're telling everyone, yay, 6G's coming, get ready, right? I mean, that's a 20-year exercise to get, and we're not even done rolling out 5G. So, I think we need to be careful, and it's especially when you go to the consumer space, when maybe those people are not as tech savvy as the people in this room, right? We need to do a better job educating people, okay, where we are. Yeah, what's coming is exciting, and it's gonna be exciting. But don't expect to have it 2 weeks ago.
I think in the industrial space particularly, that kind of network refresh model is toxic. I still talk to customers today who still talk about when the 2G network was sunset and what it did to their businesses. They had to go, in some instances, they went out of business because the physical cost of updating devices was too much for them to be able to bear. So every time they hear, fill in the number XG, it's like PTSD. I mean, they've been through that process before. And I think, from my perspective, and a large part of what we're trying to do at Blues is make that irrelevant. Try allow you to pick the best network technology for the job at hand, and be flexible enough that when that changes, because every cellular network will sunset at some point in time, when it changes, to minimize the cost involved in upgrading to the next network technology that you want to choose. Our approach is a particular one. There are different approaches. Our approach is that you should be able to pull out the radio card and stick another one in, and nothing else changes. You don't have to make any code changes. You don't have to change your business model. You don't have to change anything at the back end. Everything just carries on working. In fact, one of our customers recently built a demo where they pull out the card, put another card in, and the device carries on sending data regardless. But there are other approaches to achieving that. But when we talk about new technologies, yes, it's very important in consumer, but it is toxic in the industrial and enterprise space. Customers are literally holding off doing anything, trying to wait for a market that is perpetually in flux to stabilize. And as a result, they're 10, 15 years down the line, they still haven't deployed a solution that might have helped them commercially.
It's interesting. I'm hearing from telcos that they're getting tired of it as well because their customers don't like it. And they're saying, 5G, what else? We don't really need a lot more. Maybe that's the same thing that people were saying 20 years ago when we first got wireless connectivity into phones, but for data. But we're getting to a point of the returns are much more marginal now than they had been. And what the telcos are saying, we just want to focus on Open RAN. That's where we're interested, not in 6G. That can wait and push it down the track. So it's not just your customers, but the guys in the middle as well. Then.
They also got burnt by huge license fees, which started with 3G. When governments realised that they could charge billions of dollars for spectrum, every time a new technology comes along, it's like the hand is out, and how much more do you want to pay us for the spectrum that you need to stay in business? It's kind of crazy.
So it's the same story with the satellite convergence. It's all about the suppliers just pushing this through. They've got this huge 3GPP design. They go, how do we redesign this to allow us to sell more equipment?
Yeah.
And that's just a simple driver for that industry, regardless of whether there's actually benefit to the end users.
Yeah. In my experience with customers, that they don't really care what the bearer technology is. They just want their data.
Does it work?
Off their device, full stop. And Carmen, you mentioned antennas often being an afterthought, a very important feature of these connected devices. Tell us more about that. How do we educate the builders of these kinds of tools to start thinking about antennas before they finish the rest of their design?
So this is a task we have been doing for many years. As you said, it's really education. When you start talking to some customers and you say, okay, tell us about your device. Oh, it's too early. It's like, as long as you know there is a project, it's never too early, because you already know more or less what's the size of the device, what kind of technologies you want to integrate, and that's when you need to think about it. So, we partnered with, our customers, they are, the biggest in the industry. We go from cell phone designs like Samsung to, automotive and all the different kind of applications. The biggest customers, as long as they know they have this project, they will come back with kind of the form factor, and then we will tell them where to place antennas, and then they will design the whole device based on that, instead of coming with us with a device and say, put the antennas on it.
Right.
That's the real thing to do. And then, as I said, there is a different kind of ways to do it. Like, as I put an example, EcoStar Mobile that we have in our booth. We have a reference design where you have a very high power module that you're using just with cheap antennas. We are able to connect with satellite. We have some case study with going from the north of UK down just with the satellite connectivity, with a very, it's like 3 times 1 millimeter antennas,
Wow.
and they connect perfectly. Now, we have released this together with EcoStar and Murata, another solution where you have a very low-cost module, which is cheaper, as we said, because cost is very important in IoT. But, of course, you need to compensate that lower power with a better antenna. In that case, we have circular polarized patch antennas. And now we are working on new things coming in Q1 as well in that direction, because you can have bigger antennas. The traditional satellite, it's bigger than the IoT devices. So we need to make something that is good performance, cost efficient, not big. And this is what we are working on. Mm-hmm.
We have 13 and a half minutes left, and I've taken up all your time for questions. So let me open the floor and take questions from the audience. Yes.
Let me start with a question. First question direct to Dwayne, but also open to everyone here. So you guys talk about the integration of the radio at the front end and also backhaul. Can you give us some examples of specific vertical industry deploying those type of IoT solutions? What type of radio they choose? What type of backhaul solution they choose? Just give some examples in terms of dominant kind of configurations. I'm interested in hear about Bluetooth low power as well in different vertical industry, like retail, like hospital, like the transportation, and those areas. Just to give some concrete examples would be great. Thanks.
Right. So I can talk a little bit about a use case for Bluetooth as an example in I call it smart restrooms or hygiene. And if you visit any of the restrooms here and use them, you might actually see multi-tech technology because they're automation. It's automation around faucet control. It's automation around some of the dispensing systems you might see here. That's IoT enabled, but it's actually not WAN enabled. So you actually have local BLE for configuration and whatnot, and you can report that. We're taking that the next step from a standpoint of bridging BLE to more remote management if you want to have other telemetry data associated with the performance of a restroom, if it's being used, if any water leak detection, et cetera. So that's a real use case in IoT. It's not a remote connected one, but today it's a local connected one for configuration management. We're using multiple radios to address pest control on a global basis with regards to traps and for hygiene related to kitchens and retail, et cetera. And that's a LoRaWAN use case, but it can be a BLE use case as well. But typically it's backhauled over cellular, and that's about meeting compliance regarding responding to different events that could happen at a location. So those are two concrete use cases. Those are at scale. Those are using IoT technology today.
Alistair?
There are two great marriages in Vero technologies. I think the first is cellular and Wi-Fi, where you see a lot of devices that use cellular when they're out and about. They use Wi-Fi in the local area, in their campus, when they're in the office building. The new one I'm seeing is LoRaWAN and satellite and this is largely why we introduced LR FHSS as a new technology that runs on LoRaWAN a few years back, because the marriage there is it takes the strength of LoRaWAN for wide area, low cost, low power coverage, and it compensates for the big gap in that, which is what do I do when there's no network? And so that combination of, well, when someone steals it, I can use satellite to phone home, and when it's in my warehouse, I know where it is all the time. I think it's important for technology providers to kind of understand those combinations and make it easy for people to deliver those combinations, both at the edge device itself, but also obviously the network infrastructure to minimize cost there. But those are the two big ones that I see.
So you're talking about like supply chain and logistics, warehouse to shipping to ground transport.
If you look at where always had to do, which is understand the condition of their product, understand the location of that product, understand how it flows through an increasingly more complex supply chain. And that kind of model can be applied to both agriculture and food manufacturing, cold chain, you name it. Yeah, it's both of those use cases are centered around that kind of end-to-end world where your object transitions through multiple different spaces which have different access technologies available to them.
Right. Any thoughts from you two?
Well, I also wanted to mention for satellite IoT, like sensors. Last year I was in the panel discussion about the IoT for the rescue of the environmental, conditions. There's a lot of sensors in the forest for the wildfire forest. Sensors in the middle of the desert. I mean, there's many different types of applications where they don't have terrestrial connectivity. So I think this has been one of the first projects or applications we see in satellite IoT, which is real. So there are projects already, products in the market doing that.
Anything to add, Rick?
I'll leave some more time for other questions.
Okay. Anybody else?
Hello.
Hi.
General question. Not an IoT expert, so I really appreciate the comments on simplicity. I think that's really important. I work for an off-road vehicle manufacturer, so some of your comments around 5G and satellites, figuring out how that works in off-grid, I'll say, environments is really interesting to me and my company. So if any of you could just kind of speak a little bit more on that technology, that capability, how you connect vehicles where there isn't a satellite tower, and what type of technologies are coming, if they're here today or if they're going to be here in 3 years, 5 years, 10 years. Thank you.
Well, maybe that one I can start off with that since
There.
I'm in the satellite business. So I think what I see in motor vehicles is, in 5G at least, there's quite a demand for telematics and a lot of data. There are systems coming down the line. The issue is whether there's going to be enough business cases to support the use on satellites. So right now, I talk to all the satellite owners are saying, yeah, it's coming, but when you talk to the telcos don't know that there's really a business case there for them to support the investment in satellites. So Starlink's building thousands of satellites on the hope that they're going to get enough revenue from telcos, but whether the telcos are there or not is questionable. So there's a question about whether there's any longevity in the 5G satellite space, because there's not enough, there may not be enough business to support that. So that's the first comment that I have. But if you go there, then if it gets there, then you're going to be able to basically replicate what you have in the 5G cellular in terrestrial in the satellite, which will be great, and it'll work around the world.
Yeah, and I think those kind of off-road heavy equipment operating in faraway distant places is probably almost like the killer app for that.
Yeah.
To drive the adoption of that. Because when you're dealing with a potentially $1 million piece of heavy equipment, you damn well better know where it is at all the times.
So that doesn't require 5G though. So you can have geos have been doing that sort of stuff for a long time, and so so have Orbicom and Iridium have been doing it, so they can do it. The geos have a lot of capacity to do this stuff. Again, it's just about making sure that the 5G can work. For us, we're at the low end, so what we want to do is provide connectivity everywhere, but it's about alarms and small amounts of data, and doing it very cost efficiently. And so we can help you unlock a car. We can help you with emergencies. We can have a text messaging system within the vehicle without having to go to the extent of having 5G.
Right.
And we do that over existing geos so that it's basically available when we start our network operating in November around the world. And you'll be able to get very high reliability and at a very low cost. So we have the capacity on the satellites to send 30 billion messages a day. So there's plenty of room there for lots of people. They're paid for. They're there for another 20 years. So you've got pretty good certainty, and they keep replacing them. So, and you don't have the issue of devices being sunsetted as well, because we'll guarantee that we're going to make our technology will just be there forever.
Yes, sir.
Hi. So we talked about the transports change. There's a multitude. Many of them pre-installed around the world. So let's just say that's a sunk cost. And then talked about we're trying to orchestrate these disparate networks. A lot of the traditional way of doing that has been through custom hardware, like adding something to. But do any of you see a place for the Android or Apple end user device, like the thing that is in the pockets of everyone, or in the case of Android Automotive? Can that be a software mechanism? Is there applicability to be that orchestration layer?
I mean, I'd argue that if you look at the adoption of cellular technologies, that there were three big ecosystems now too. There's Android, of course, there's the iPhone ecosystem, and there was Windows Phone for a while. That uniformity of environment, regardless of the underlying hardware, is what enabled multiple vendors to come to market and all of the innovation that we all have in our pockets today. So yes, that principle of make everything the same way you can and optimize for difference where you need to is one that I think needs to be more prevalent in IoT, where the software layer that runs on the edge device is the same regardless of the technology. The actual hardware and the antenna that will be tailored to the specific application, but the data flow that comes off the back end, is the same and ends up in the same destination that you want. The difference in embedded devices is you don't have the same luxury of capacity to support a big operating system that can hide all of that. So you actually have to design the system, I'll say more intelligently, but that's not really what I mean. You have to design the system with much more understanding than you have to in an Android world. Because as long as I can run the operating system on the device with Android, great, I've got a world of things that I can actually do. In the embedded world, everything is much more constrained, and there's yet to be a widely adopted Android-like model in the embedded space. I think part of that's because going back to the 50 billion devices, et cetera, everyone was so blinded by the numbers, they thought there was all this money to be made. And so they went around and licked all the cookies and tried to do everything and didn't cooperate. As Carmen said, what's happened in the last 5-10 years is people have realized, like, oh crap, we actually need to work together. These things actually need to be usable to a customer. So I have hope that that model will emerge. We're trying to do our bit at Blues to push that model forward. But I do believe that model will emerge. In this space. It has to.
I think the Android, what you described, is actually the model. I mean, it is a form of gateway. It's an intelligent gateway. To Alistair's point, we're dealing with a lot of more constrained devices, so you have to be more specific on the use cases. But in general, it should all operate in that way. That's the vision of what we need to achieve as an industry, and as a technology vendor, we're striving for that sort of view of really kind of making the hardware abstracted completely from all the value. So we talk about connectivity convergence. How about information convergence, which is that layer of software that really kind of delivers value to you as an end user. Yeah. Hardware just needs to be abstracted well enough so that we can just plug and replace it. But yes, I think that's the holy grail of where we need to get to.
Thanks. I'd like to talk to you after this.
Got to be quick.
Yeah, we have 25 seconds. Let's go.
Hi, my question is for everybody on the panel, and I was curious from an industry standpoint, how has the advent of edge AI changed the technical expectations that the consumers have from the IoT industry? And what are some technologies that are going to gain traction because of the huge amounts of data exchange that is required for AI from an IoT standpoint?
I think the data from AI is kind of being generated today. It doesn't have to be all at once. It's in drips and drabs, but combined, it's going to have a meaningful impact. So I think AI is going to have an impact. It's not, there's a lot of hype around it yet, but it hasn't been realized in a lot of products. It's something obviously from the standpoint of how do you make your solution work better? How do you make it more resilient, reliable? How do you cyber-proof it better with AI? Those are some of the topics that are going to be relevant in the industrial IoT or in the embedded space going forward with AI. And who knows, this might be the last panel without AI heads up here just trying to answering these questions for you.
Yeah, I think what we're seeing today with AI is device optimization, network optimization. Those kind of applications are happening right now and have been actually for a while. So as we move from that to new exciting things, we'll keep your eyes peeled. But I'm getting the hook, so we've got to go now. Thank you, everybody, very much. Thanks to our panel.